Today I will talk about my very first Python project that is named as Automated Concrete Mix Design, which is under the code of American Concrete Institute 211.1. This is the latest code available now, and the world follow this code to do the concrete mix design. And if I show you the syntax of my program, and this is the program. This is a huge program, and I have inputted the data table which I have copied from the manual of ACI concrete mix design. This is the manual of ACI concrete mix design, and if we look at that, we have different tables that is important, and I have inputted all the tables there. So if I run the project, let's run the project and run the app. If I look at this app, and this is the app here, and which I have deployed using the Streamlit. And at first we need some values. Related to specific gravity of coarse aggregate, fine aggregate, fineness modulus of fine aggregate, and specific gravity of cement, the slump value, what type of concrete we are using, it is air entrained concrete or non-air entrained concrete, and every kind of value we need to put down here, and the app will show you the output. Let's dive into the program. At first, select the specific gravity of coarse aggregate. If we look at our manual, we have an example here, that is sample example. We will use this file to check if my program is okay or not. This is our sample computations, and let's check. They have used non-air entrained cement, and the specific gravity of the cement is 3.15. Okay, let's put down the value here. The value of the specific gravity of cement is 3.15. okay, next, coarse and fine aggregate in each cases. Okay, standard, they have maintained the standard, and the coarse aggregate has a bulk specific gravity of 2.68 and an absorption of 0.5%. okay, we will check the absorption later. At first, put the value of specific gravity of coarse aggregate, that is 2.68. okay, 2.68. The next thing is that they have also used the fine aggregate, and the specific gravity of the fine aggregate is 2.64 and the fineness modulus is 2.8. okay, let's put down the value here, that is 2.64 and 2.80. okay, we have got the value of specific gravity of fine aggregate and coarse aggregate, the value of fineness modulus, and the value of specific gravity of cement. These are the values. okay, in the next step we will check the 28-day compressive strength, that is our F prime C. Let's check it. They have used the concrete, this is the question, and they have used a concrete whose F prime C is 3500 psi. okay, let's write down here 3500 psi. okay, and the next program is input the value of slump, that is we need to put the value of slump range here. Let's check it, and the desired slump is 3 to 4 inch. That means the slump value is 3 to 4 inch. okay, we are putting the value here. My desired slump value is 3 to 4 inch. okay, now we have to select the type of concrete and check here, and it is written that the structure will be exposed to severe weathering or not. If the concrete is exposed to severe weathering effect, then we have to use the air entrained concrete, and if the concrete is not exposed to severe weathering effect, we can use the non-air entrained concrete. So let's check. okay, the concrete required for a portion of a structure that will be below ground level in a location where it will not be exposed to severe weathering or sulfate attack. That means they have used the non-air entrained concrete. okay, let's select the non-air entrained concrete. okay, we have selected the value, the non-air entrained concrete. okay, Now we have to select the value of water cement ratio from a table, and that is table 6.3.4a. We are going to the table 6.3.4a. Yes, this is the table, and let's check if our compressive strength is 6000, and if it is non-air entrained concrete, the value will be 0.41. So let's check our value, that is 3500. So it lies in between these two. I'm zooming the page, and this lies in between these two, that is our 3500. So after calculation we got the value is 0.62, and let's check the value, recheck the value, that is, yep, the value is 0.62. From the table we get the value is 0.62. So this is the table, and from the table we are using non-air entrained concrete, and F prime C value is 3500. So it lies in between 3000 and 4000, and the value is 0.62. Okay, we have put the value here, and again we have to select the slump range. Why? As we have selected the slump range here, why we need to select it again? We have to select it again because this table is dependent on the slump range. If we look at this table, let's go to this table. Yep, this is the table, and check, we have to put down the slump value here, and they will give me the amount of water. So if we want to find the amount of water, we have to use this table. So let's dive into the table, and the slump range is 3 to 4 inch. Please check, if I select 3 to 4 inch here, the value are changing, and if I select 6 to 7 inch here, the value are also changing. Everything is changed related to this table. Okay, so we are putting the value here 3 to 4 inch, as our slump value is 3 to 4 inch, and after putting the value we have to select the maximum aggregate size. Let's check what is our maximum aggregate size. Okay, they have selected their maximum aggregate size is 1.5 inch. So we can select the maximum aggregate size, that is 1.5 inch, and according to that value the water volume will be 300 pound per year cube. So we are putting the value here 300. Okay, now we have to select the percentage of entrapped air, and if we look at this table, our maximum aggregate size is 1.5 inch. So our amount of entrapped air will be 1. We have to select the non-air entrained, and we have to put down the value of 1. For check, if we put the air entrained, our table is changed, and it is changed according to the mild exposure, moderate exposure, and severe exposure. As our value is non-air entrained concrete, we are putting down the value 1 here. Okay, our entrapped air percentage is 1. Now the program will automatically calculate the value of cement content, as we have put down two values related to that. The first one is that we have selected the water cement ratio, that is 0.62, and we have also put down the value of water is 300 pound per year cube. So after the calculation they will give me the desired cement content, that is 484 pound per year cube. Let's check the value here, if it is okay or not. Yes, it is okay, it is 484 pound per year cube. Okay, we are going to the next step. Calculate the amount of coarse aggregate. Now we have to calculate the amount of coarse aggregate, and related to the fineness modulus value of the fine aggregate. There is a table in the manual. If I check the table here, let's check the table. This is the table, and where we can see we have to put down the value of nominal maximum size of the aggregate, and we have also have to put down the value of fineness modulus, and after these two types of value they will show me what is the volume of the dry rodded coarse aggregate. Okay, let's go to our app, and we can select the value here. Our maximum size of the aggregate is 1.5, and our FM value is 2.80. So we have to think that our 1.5 is on the number 4, and let's check 2.80. Yes, this is the FM value of 2.80. We can see that FM is 2.80, and after and from the value we can see our volume of the coarse aggregate is 0.71. Okay, we are putting down the value here 0.71, and it is yard cube. So we have to change the value in feet cube, and if we can change that, we have to multiply this value with 27, as 1 yard cube is 27 feet a cube. Okay, now we have to put down the value of dry loaded unit weight of coarse aggregate. We can check the value here in the question, and the dry loaded weight of coarse aggregate is found to be 100 pound per feet cube. So here the value is in feet cube, so we had to convert the value into feet cube. Okay, let's put down the value here 100, and after putting down the value, we can see that the quantity of coarse aggregate is 1917 pound, 1917 pound. Let's check the value in our manual if it is okay or not. Yes, the value is okay. Okay, let's check the next step. Now we have to choose the method of mixing. Okay, this is an important thing. We can use two types of mixing method, that is our volume method and weight basis method, and we will show both the method here. And if I select the weight basis method, at first we have to select the weight of the concrete. What is the weight of the concrete? Okay, now our nominal maximum size of the aggregate is 1.5. we have selected the 1.5, and the concrete we are using, that is non-air entrained concrete, and following this value we can see the value is 4070 pound per year cube. So we have put down the value here. Okay, these all are the value we have calculated till now, and if we look at this value, okay, we will look at the value at the table. Okay, the weight of fine aggregate is 13 and 69 pound. Okay, this is the table, and we can check the table using our manual if it is okay or not. This is the concrete weight based on the weight, and this is based on the volume basis. So as we have used the weight basis, we will check this table. Water is 300 pound, and cement is 484, coarse aggregate is 1917 pound, and fine aggregate is 1369 pound. Let's check the value. Water is 300, cement is 484, coarse aggregate is 1917, and fine aggregate is 1369. That means the program is okay till now. Next we have to find the value of moisture content and absorption in coarse aggregate and fine aggregate. Then we have to deduct this value from the water we have used, as the absorption water, absorbed water, and the moisture present in the aggregates, we are not using it into the mix design, so we have to deduct this value from the water. So let's put down these two values here. If we look at the manual, we can see that they have used the moisture content of coarse aggregate is 2% and fine aggregate is 6%. We can get this value from the lab experiment. Okay, let's put down the value here. The moisture content of coarse aggregate is 2 and the moisture content in fine aggregate is 6. And if we put down the value here, we can get the weight of the coarse aggregate. And before that we used these value. These are the dry weight of coarse aggregate and fine aggregate. And after putting the moisture content value, we can get the weight and the weight of the coarse aggregate and weight of the fine aggregate. And here is the absorption is coarse aggregate, and we can check this value here. And the coarse aggregate absorption is 0.5% and the fine aggregate absorption is 0.7%. Let's put down the value here. 0.5 and 0.7. Okay, and after putting all these value, we can get the estimated batch weights for a yard cube of concrete that is necessary. Now we have to calculate if we want to build a cylinder, then we have to convert the cylinder volume into yard cube, and we can just easily multiply this value with that to find the value of weights of the materials to build in a concrete cylinder. Okay, let's check this value. Water to be added is 199, cement is unchanged, and the coarse aggregate weight is 1955 and the fine aggregate weight is 1451. Let's check the value here. 199484, 1955 and 1451. Yes, the program is totally okay. Now if we want to do the volume basis, if you want to check the volume basis of the coarse aggregate, mixed design, then you can do that. We have to select the volume basis here, and we can see that they have captured all the values I have put it in the previous sections. And if we go here, yes, we are using the volume basis, and volume of interrupt here is 1 as we have used it earlier. Here the interrupt here is 1, so we have put the value 1, and if the moisture content is 2, if the moisture content is 2, yes it is 2, and moisture content of fine aggregate is 6, yes it is 6, and we have to select the value of concrete, weight of the concrete, that is our 1.5 is the maximum size of the aggregate, and if we check the value, that is 4070, similar to the weight basis. And after putting all this value, absorption value is unchanged, absorption of fine aggregate is unchanged. So after putting all the values, we can get the new value of water, cement, coarse aggregate and fine aggregate. Now if you check with the manual, you can see that this is our weight basis, and in the app we have done the volume basis. Check the value here, the water, and it is quite similar, quite equal to the value of weight basis, as we have rounded the value, so 1 or 2 value can be changed from that. So the water is okay. If we look at the cement value, it is unchanged. If we look at the coarse aggregate weight value, it is also unchanged. But if we look at the fine aggregate value, it is 1451, but in volume basis the fine aggregate value is 1397. This is my project, and if anyone wants to run this project, he just need 2 to 3 minutes to find the estimated value of the materials of the concrete. It is very easy to use. Anyone who doesn't have any knowledge about any kind of programming can use this app very easily, and this is in the development phase, and I'm sharing the app with you so that I can get the bugs or errors in my project and develop it again. Thank you everyone.